Hi everyone, my name is Ruitao. I'm the co-founder and CEO of Laminar. We are a team that's passionate about DeFi, and we are building a number of DeFi solutions on top of Substrate. Today, I'm going to share a short introduction of who we are, what we do, and then I'm going to go through some real business case and scenarios to help explain like what is new possible, like what sort of new possibility we can do differently if we build on top of Substrate, comparing to other like major smart contract platforms. So this talk will be slightly different from like, I'm not just going to introduce like what we are doing like commercially. I'm gonna share first-hand experience like what we encounter during our development in Substrate. So we are founded August this year, so we're a pretty new company. We are a team of blockchain experienced engineers. Currently, we have around 7 people, and we're looking for more engineers to join us. So the company is pretty much engineer focused. However, we are backed by financial institutes that not only provide resource, but also provide financial expertise to help us to design these products by combining the real world financial experience with blockchain. Most of the team is based in Auckland, so it took me like 24 hours to fly here. I'm still very jet lagged. The time zone is completely different. So that is actually an issue when communicating with the Web3 teams, like their early morning is our late night. So excuse me if I still have some glitch in this speech. For me, it's late night time this. We have presence in Singapore, and recently we have also have a team working from Shanghai. So talk about our projects. We have 2 DeFi products that's currently in our pipelines. We have FlowChain, which is a synthetic asset and margin trading platform. We also have Alcala Network, which is a collateralized stablecoin. I think I'm going to explain what Alcala Network first. It's a concept that's very easy to understand. So it's a collateralized stablecoin. It's built with multi-collateral from day one, and with some unique aspect of the Polkadot / Substrate capability, we are able to do something that's not possible with the other smart contract platform. For example, we can use Bitcoin as collateral once the bridge has proven to be successful. The initial plan is to have DOT as collateral and create a stable coin. We'll call it AUSD. And next, for FlowChain, we are a specialized platform focused on synthetic assets and margin trading. With FlowChain, you can pretty much trade anything that as long as it has a reputable price fit, and as long as there's a mature market with liquidity, you can source. To put it simply, to put it this way, is that we are able to decentralize the liquidity from the centralized exchange through our protocol. I have a few slides here to make it better to understand how the Flow protocol works as an example. And later on, I will use this as scenario to say that how we can do this differently with Substrate. So first, the protocol is going to decide that there should be a market. In this case, we're using the Bloomberg as the oracle and to fit the price for Euro USD into the Flow protocol. And the liquidity provider sees this opportunity and see that, hey, I should join in and provide liquidity in this Flow protocol. So he lock in $100,000 with a bid and ask spread. More on this later, like what is the spread, and more on this later, like why there will be a liquidity provider. And later on comes a trader, sees the opportunity to trade Euro USD in a fully decentralized way. So the trader happily lock in $1,000 and the position is open. The logic is now enforced by smart contract and it's dictated by the oracle. So as the price update on oracle, the profit and loss is calculated in real time, as you can see here. So that's pretty much the oversimplified workflow of how the synthetic asset and margin trading works. Of course, there's a lot more other stuff we have need to take care of, such as like the swap, interest rate, and things like that. So that's the general idea of how it works. So the question, obviously, we're asking that why would a liquidity provider losing a lot of money on chain by backing this liquidity? The answer is that for mature marketplaces such as Euro or USD, the liquidity provider is able to hedge the risk anywhere. For example, Deutsche Bank, in this case, they are the largest forex broker, and anyone with trading experience shouldn't have any problem sourcing this sort of liquidity. And we talked about the bid and ask spread early. Because this is a centralized exchange, it has much more liquidity, it's much more mature place. There's no problem for a liquidity provider to be able to get a slightly better spread if the liquidity provider chooses to hedge the risk using the centralized liquidity. And that will end up with a small fee, and that will be the profit for the liquidity provider. Obviously, some liquidity providers choose not to do that. They are gambling against their traders, and this used to be a huge problem with the centralized exchange, because later on, if the liquidity provider loses a lot of money, they might not want to pay out. But in our cases, this is okay as well, because their character is locked in a smart contract. There's no way they can run away from that, and it's like the profit and loss for the trader is guaranteed. This is also a new source of revenue for traditional broker. Like if they want to get into the blockchain world, they can now utilize our protocol to have a new source of revenue. And obviously, like any existing DeFi solution, there will be a sort of liquidator to ensure that the system has integrity. Like a risky position will be liquidated by the liquidator with a small reward from the trader. More on this later. So the idea of the flow protocol is to able to, because as long as there's a reputable price feed, and as long as there's liquidity provider willing to offer the liquidity, there should be more variety on blockchain, and there should be more traders. We can offer Bitcoin price index, we can offer Apple stock, or things like that in a decentralized way. Because we are a product level protocol, it doesn't really matter where we implement our protocol. So we have implemented the first version of the protocol on Ethereum. It's currently live on the testnet. We have a front-end dev as well, and we are now heavily working on a Substrate solution in this flow protocol. And if you want to test that right now, you can actually go in there, and it's on Coven. You can get some fake DAI and then start to trade on there. Obviously, there's a question like, how do you bootstrap these products? Like, there's a chicken and egg problem. Like, where do you get the liquidity from? Where you get the initial liquidity provider from? Because we are backed by financial institute, we're lucky enough to have like 2 liquidity providers that's willing to work with us. We also have another arm that's working on OTC service, because some of the traders that we're trying to target, they are not crypto users. We're trying to target mainstream trader that has interest to get into the blockchain world. They would like to trade Bitcoin, they would like to trade their traditional instrument as well. And we are working on that. We are greenlit by a major crypto bank to provide OTC service. We also have a custom acquisition network with a significant amount of high-value traders that we are able to convert. So those is how we bootstrap the flow chain. Now I'm going to talk about the possibility that it's possible when we build on blockchain on Substrate. I'm going to compare how we design the stuff on Ethereum and how we design the stuff differently on Substrate. I'm going to cover a few topics. Ranging from block time, transaction fee, to upgradability, or things like that. So this is the possibility that we found when we designed the flow chain. So block time. Obviously, block time is the how fast you can update information on the blockchain. And what we found is that in the current major smart contract platforms such as Ethereum, block time is not guaranteed, and block times tend to be very, very slow. And we found that the longer the block time, the larger the spread. And also, the longer the block time lead to risks such as front running. When we talk about front running, it's basically like with Oracle fitting the price into the blockchain, the information on blockchain is always lagging behind with the real choose of the data. And in this case, you need to have some sort of spread to make sure that no one can predict the future, because people can predict the future if your Oracle is lagging a little bit behind. But that is the case like this. In this case, like if the price of this particular asset get too volatile, and someone is able to do a transaction, like someone sees this, and then they place an order right before the price getting updated on Oracle, they have an upcharge opportunity here. And we don't want that to happen. So you will have the only thing you have to do is to increase the spread, but that ends up with like a worse price for the trader. With Substrate is that you get your full flexibility to design your own block time, like as low as 2 seconds. That's what Chainx has been doing. It's maybe too extreme, but you can do that. There's also a separation of block time and finalization time. But in the world of DeFi, a faster block time always means to better spread and better trading experience. The trader that we are talking to, they're already quite used to like instant confirmation, like click a button, the order is done. And if we do it on Ethereum right now, it's like you click the button, you wait for a minute and hope that your transaction is being mined. So Oracle. The Oracle design is also slightly different in the way that we implement that in Substrate. On current major smart contract platform, generally you require a fee for you to update data on the blockchain, so Oracle is no exception. You have to pay fee to update data on blockchain. And we estimated it will cost us $20,000 per year for one Oracle to update on the Ethereum blockchain for every 3 minutes. But as for Oracle, you want the Oracle to update as fast as you can because that's end up with a better trading experience. And also with the current major smart contract platform, there's no quality of assurance that your Oracle transaction is going to be mined. Like you pay some certain gas fee, you hope that it's gonna be mined. And whatever happens, like if there's a crazy dev game that's getting so popular and then your Oracle price is getting outdated because your transaction is not getting mined, that's a huge problem. With Substrate is that you have the full flexibility to design your own logic. Like some cases we've been thinking like there should be a whitelist of Oracle address that can submit the data for free. Because you can't allow free transaction. You will end up with like spam causing the network to be lagged. But with Oracle, you can have a whitelist of like, hey, this X amount of Oracle, they are approved. And you can have also like, you can stake native token in order to get to this free transaction. You can also say that there's some sort of governance model you can design that some particular address can submit the transaction for free. Reward can be even awarded to Oracle operators. Like feeding the price into a blockchain should be like an activity we should encourage. So this is also possible with Substrate design. And also there's operational transaction that we can have some sort of assurance that the Oracle transaction will be always prioritized. So in our cases, this can be free plus prioritized. And as the liquidity provider, they have interest in updating their price as well. They might want to change their spread. And because they stake $100,000 here, we can say based on your staking, you can also get free update on your pricing. The next topic is about transaction fee, and that's echo what Joe just talked earlier. Like in the current major smart contract platform, the blockchain has counterintuitive fee model. Like DeFi user pay double fee. They need to pay for the native gas fee of the underlying blockchain. They also need to pay the protocol fee. And we find that it's very, very counterintuitive. When we talk to like traders, they don't have the idea like, why do I have to pay Ether as fee when I want to trade some USD? With Substrate, we have the capability to design the fee model in full flexibility. We can say that fee is payable in one token or in various tokens. Like if I'm trading USD, I will expect that my fee will be deducted from USD. If I'm trading Euro, I will expect that my fee will be deducted in form of Euro. And there will be pathway to free transaction as well. Like if we are designing the Alkaline network, we would probably say that, hey, if you have X amount of USD, then you get to transfer the USD for free for X amount of time. So that also open the possibility to freemium model. Like if you have something like you can have free transaction 5 times a day, and after that, it will actually start to charge you a fee. Like this is all possible with Substrate because you have the option to customize this. And in our cases, like this, if this trader trades this particular position and is trying to close the position, the fee will be charged in US dollar, and that will be okay for the underlying flow chain to just recognize this as a fee. And it can happen like complete opaque to the user. At the back end, they actually buy back some of the native token and burn it. But for the user, they doesn't know that this happens. And this is basically like we giving dividends to the token holders. And all this design is possible. The next topic we talk about is liquidation. So the liquidation is the liquidator bot we talk about. I'm pretty sure most of you are familiar with the liquidation bots, such as like Polkadot has liquidation bot, Compound has liquidation bot. I mean, the liquidation bot is actually more of like a trade-off rather than like by design, because most of the blockchains generally doesn't have an automatic scheduler built in. And to maintain system integrity, bot is incentivized to run off-chain to monitor on-chain position. You end up with problem like the actually duplication of logic, because sometimes you have on-chain contract and you have off-chain bot. Your off-chain bot have different code bases, most of them written in Node.js. And you also need momentary reward from trader to maintain, so it's like it's costly for trader in some way. It also has safety issue. Your bot might not be run, your logic might be out of sync with the on-chain contract. So generally, I think it's a transitional solution rather than an ultimate solution. And also this end up with like the counter-productive incentive. Like there has been a research article that in the Compound protocol, if you pass through a particular liquidation line, the actual liquidator bot will push you into more insolvency. So with liquidation, we think about that, hey, maybe in our blockchain design, we can build this liquidation built in within the node with the validator node. So there's already an off-chain worker talk earlier by the parity guy. So I think this is very good. Like we can now put the liquidator bot right inside the node, and they share the same logic as the liquidation, how the liquidation should be happened. It also means that if we can tie the liquidation into some sort of slash event, like if you don't force to close risky position, you'll be slashed, then it's actually more safe. And then there's just one place to run it, and there's no longer fee needed to maintain this system integrity. And so that is liquidation. And the next step, I'm going to talk about upgradability. So this is the money Lego that's so popular this year. Everyone's talking about this money Lego, and this is good. And people start to build money Lego like that, and this is great, until it becomes something like that. It's so complicated, you don't know when it's going to collapse. And especially think about that, hey, once that piece is there, you can't move it. So in order for you to replace that pieces, you have to tear down the whole building apart and then to replace that pieces. This is actually what's happening right now, because the Polkadot just migrated to MCD, and I have to migrate my SAI to DAI. So this is actually very, very not user-friendly. Like I have to migrate my money. So allowing seamless upgrade of protocol without affecting existing user experience is the key for bot user adaptation. With Substrate and Parachain, it's like you think less about how you design a super technical upgrade pathway for your protocol. Instead, you start to think about how you can come up with some sort of governance model that ensure that your protocol can be upgraded. And the whole upgrading experience is much, much better. There's no migration. Well, they're seamless migration. The end user doesn't feel anything. And there's no fork. And the final topic I want to cover is the security of this. Like, we want to design this flow chain, and we want to design all this custom solution, but they are not possible. Like without the shared security model of Polkadot, it's actually very hard. So the general conception idea is that if you want to run a product level protocol, you should run it when the base layer is much valuable than your product. Because otherwise, like this is good. Because otherwise, if it looks like that, it's easier to attack the underlying layer. So people can attack the underlying layer and to gain the value that's on top of that. And this become extremely difficult to judge if like the underlying layer actually, because in order for you to judge the underlying layer blockchain's value is very, very hard. Some of the existing protocol, it might seem that it has a lot of valuation, but it might end up to be like some of them is not really solid or not very credible, because you need to take account into like token value, you need to take account into like liquidity of the token, the actual usage of the underlying network. So for us to launch this flow chain with fully customized design, there's just few options for us. We can deploy this in a smart contract platform such as Ethereum, but then we cannot customize all the stuff that I talked about earlier. We lost the flexibility. Or we can raise enough capital to become a viable proof of stake network. We can probably do that, but it's not viable for every business to raise a lot of capital and become a viable proof of stake network. So the share security model of Polkadot is actually a very, very good viable path for you to launch your customized network while without sacrificing security. So there's already project pay as you go, there's project for long-term lease. And I believe it's a pathway for viable business model and growth. So all of this that I talked about earlier is not possible without this shared security model, because we can just launch a blockchain with few nodes and it's still pretty centralized. Okay, so that's enough good stuff for Polkadot and Substrate and everything that's built by the awesome Parity engineers. Now there's few challenges that we experience when building our product as well. So I'm going to share that as well. So one challenge that we face is that Substrate code is evolving, and we are at bleeding edge development. So one story that we heard is that one day the Parity guy, they changed the name from SRML to palette, and then later on the day after they changed it to frame. They actually drive one of our developer crazy, because well, as a non-English native speaker, he spent a lot of time to remember palette and palette. And then the other day, they just say that, hey, we don't need to do it anymore. We just change it to frame. But I mean, that's one experience that you have, like when you're working with bleeding edge developments. There's breaking change, there's lack of documentations. So potential solution for that is be prepared, like expect chaos. And also there's a route channel that you can talk to dev. That's very, very helpful. So just join the route channel to get hold of core devs. We find that it's a very good experience working with the Parity engineer of the route channel. So the other challenge that we're facing is currently there's lacking of standard features. So one of the challenge that we are facing is that for us to design an characterized stablecoin or to design an synthetic asset, there need to be some sort of like a token standard, like an ERC20 like of token standard, maybe called PRC20. And also there's lack of common feature and libraries. Most of the library that's currently available was for Polkadot, and there's a lot of common library that we think might be useful, but it's not available. And solution for that is like just good news. There's already a Polkadot standard proposal, PSP1. We actually submitted the first Polkadot standard proposal about forming a token standard. So that's where you can look for, like in the GitHub link there. And for the common libraries, because we are working with two projects right now, and they have a lot of common, similar requirements. So we created an Oracle module, we created an auction module, we created a multi-branch module. We turned it into something called ORML, like Open Runtime Module Library, and it's open source. We're happy to share, and you can all contribute into that as well. Like maybe we can change. We have to change the name now. It's called Frame. We may come up with some better name for that, but. Yeah, and the final challenge that we find out is that when you are designing your own blockchain, like when you are coding your runtime, it's different from like writing a smart contract. So there's lack of runtime level atomic storage modification. Like you need to do the verification first, and then make sure that your transaction is sent, and then later on you need to do the order write. And if in some unfortunate case the writing become failed, that there's no database level of rollback. So that is one thing that makes us, in terms of writing some code, it's tricky to think about that, hey, we need to make sure the write wouldn't fail. So maybe there will be database like rollback in the future, like for the runtime support, I don't know. But that's one of the experience that we would like to share. So that's pretty much the whole experience that we'd like to share. Thanks a lot. And Please follow us, and all the stuff that I showed today, including the Ethereum implementation, including the Alcala network implementation, they are all open source in GitHub. They are available for you to check. So that's pretty much it. Thank you. Any questions?
Ruitao, thank you for the presentation. It's wonderful to see higher level projects like this with actual business utility. My question is about high frequency. Do you believe that Polkadot will achieve the performance needed for high frequency trading?
I wouldn't say you'll be achieving the high frequency trading as if like you were compared to the existing centralized exchange, but it's already a huge step forward compared to Ethereum. And I think, as the underlying technology grows, it will keep becoming better and better. But for now, if we can say assume a block time of 2 seconds or 3 seconds, and we can assume some transaction have finality, then we can already do a lot of things better than the current major implementation. So we already see a glimpse of hope of what we can do. We don't think that it's going to compare to what is currently available on those centralized exchange. But still, for the early adopters, they are willing to pay the price of, like, it's not that user-friendly, but it's trustless, it's decentralized, yours forever.
Thank you.
Thank you. Oh.
This is Sayed from Web3. Could you tell me why the liquidation bots need to be off-chain? Why can't it be part of the logic of the runtime?
We think about designing the liquidation bot as an off-chain worker, so it can, for us to liquidate, it's like in the current model, you need to provide some sort of incentive, right? For now, we haven't decided where would we put it yet. Maybe we can put it in the runtime as well. But the thing is that I'm not sure if there's also for runtime is there also an automatic scheduler. The reason that we put it was we designed it and assumed that it's going to be an off-chain worker is that you can hook it to each block and it can invoke in a per block level, right? Maybe in the future we can put it directly in the runtime as well, and it can ensure the integrity of the system from the runtime built-in. Any more questions? Yep.
So when building application with blockchain, one of the challenges that a lot of developers face is that storing data, you can't store everything on blockchain. Some of the things that is not necessary, some of the things is better to be stored elsewhere. Mm-hmm. So one of the things we are here at Totem we're faced is that we're using NoSQL database to store off-chain data. Mm-hmm. I was wondering what other solutions do you face? And one of the challenges we are facing is that if you want to actually store those off-chain type data into blockchain, you can't actually make it queryable. Or if you use some of the other people we talk to, they are using IPFS to store those data, but that's actually just storing as a file. You can't actually query that. You can't manipulate or do other stuff with that. So I just love to know what they're doing to that.
Yeah, and in terms of storing the data, I don't think for our two projects we need to store a lot of data on the blockchain. There's just price feed and there's just a balance module. And for the Alcala projects, maybe some of the CDP we need to store. I don't think we need to store a lot of data, either off-chain or on-chain. There's just minimum amount of data. The reason that we talk about the off-chain worker is that I think it's just more comfortable for us to have one code basis that rule everything rather than have the liquidation logic in a completely different set of database. It's actually more of having the logic in one place rather than have to store it somewhere else.
So the off-chain data is basically stored in a traditional database in your case?
I think when you design the off-chain worker, it only runs after you have a full synchronization, right? And most of the data is on-chain for our solution. So the off-chain worker have the ability to read everything, the latest state on the blockchain. So I don't think it even needs its own database.
Okay, thanks.
Thank you. Any more questions? I think that's all. Thank you.